Okay, so let's look at an example of stormwater runoff. For this example, we're going to suppose a developer purchased a 3-acre farm in Nashville, Tennessee, and a 30,000 square foot asphalt parking lot will be placed on the plot. Local regulations require that post-development runoff be limited to pre-development runoff for a 25-year, 1-hour rainfall. We're going to find the change in peak runoff, or the difference between the pre-development runoff and the post-development runoff. We're going to use the formula Q equals C sub F, C, I, and A, where Q is equal to the peak runoff rate, C sub F is the runoff coefficient adjustment factor, C is the runoff coefficient dependent upon the type of surface, I is the storm intensity in inches per hour, and A is area in acres. So we need to calculate our Q pre, and then we need to calculate our Q post. So I'm going to use subscripts when doing this, and so we're going to do Q pre, and this is hard to write on. Let me try doing this. Alright, pre. Alright, in order to find our Q pre, we need to find our C sub F, our C, our I, and our A. So our C sub F is our peak runoff rate. So for our peak runoff rate, we need to know the time. So we're looking at 25 years, and we're going to use the chart over here that is the runoff coefficient adjustment factor, and we know that we have a 25-year storm, so we're going to use 1.1. So when we calculate, or when we figure out this C sub F, that C sub F is going to be the same for every single problem that we do, for all of the Q's that we do in this one problem, so we're always going to use this 1.1. Then when we're looking at our C, it's dependent upon surface. So we have a 3-acre farm. This is what we're going to use for we're going to use this table for our C, and we're looking at a farmland. So our farmland could be anything from 0.05 to 0.3. So when we go to calculate that, we've got to take the average of those two numbers. So that's going to be 0.05 plus 0.3, and then I'm going to divide by 2 because I'm looking for the average, and that is going to calculate to 0.175. Both of those are coefficients, so they have no units. Then finally we're going to look at next we're going to look at our I, which is our storm intensity in inches per hour. So we have a 25-year storm, 1-hour rainfall. We are going to use our precipitation intensity estimation, and we're going to look at a 25-year, 1-hour storm. Those two converge at 2.54. So that is 2.54 inches per hour. Okay? So I'm going to add that in, 2.54 inches per hour. Then our A is our area, and our area that they gave us was 3 acres. And area should be in acres, so we're good. So we can go with 3 acres. So now we're going to plug all this in up here. So we have 1.1 times 0.175 times 2.54, and I'm going to leave off the units because I'm running out of space up here, and then 3. Then when we calculate that, multiply everything together, we're going to get 1.46, and our units are going to be feet cubed per second. So that's feet cubed per second. So that's our Q pre. Now we've got to figure out our Q post. So Q post, I'm going to start it up here. Q post, we have to look at 2 different things. Our Q post is going to be our Q post farm plus our Q post parking. So it's going to be both. So first thing we're going to do is let's figure out our Q post farm. And it's very helpful to use subscripts on all of these so that you know you're going to have tons of different Q's, and this kind of helps you keep everything straight. So our C sub F, our C, our I, and our A. So our C sub F is going to be the same because all the time our C sub F is the same. Our C is dependent upon surface. Because this is farm and the pre was farm, I can use the same value that I've already calculated. Our I is going to be the same for all of them. So I'm using 2.54 inches per hour for all of my, for this entire problem. And then my area, here's where my area is going to be a little different. So we started off with 3 acres. But then we're adding an asphalt parking lot. So because we're adding that asphalt parking lot, I have to subtract that value. So from here, I'm going to draw you a quick sketch. So I would have my 3 acres, and it's great to draw this out so you know what you're actually talking about. And then I'm taking out this parking lot. So I have to take my 3 acres and I'm going to subtract this parking lot value. So since I'm subtracting it over here, I'm going to go ahead and convert. So 1 acre is 43,560 square feet. So this is going to give me 3 acres minus 0.69 acres for 2.31 acres. Now I can plug all that in. So I have 1.1, 0.175, 2.54, and 2.31. Okay, so when I take and multiply all of that together, we're going to get 1.13 cubic feet per second. Now, I'm going to go ahead and move to a new slide to do the Q post parking. Okay, that way I don't get everything all jumbled up. So we're going to do Q post parking. Okay, so we have our C sub F, our C, our I, and our A. Well, our C sub F is still going to be the same for all of it. So we're still using this 1.1. So 1.1. And my I is staying the same. That was 2.54 inches per hour. So that's always going to be the same. Now, my C and my area. Well, our C is based upon surface, and the surface is an asphalt parking lot. So I'm going to come to my rationale coefficient method, and I'm going to look for asphalt. So asphalt's the second one over. Because this is a new build, I'm just going to use this final number right here, this 0.95, because it's a brand new build. If this had been existing, then I would take the average like I did before. So we're going to use 0.95, and then our area is going to be our 30,000 square feet, but we have to convert that into acres, which we already did before. So I'm just kind of rewriting it out so that you know what I'm doing and where I'm getting everything. So when I convert this out, I get 0.69. So then I can plug everything in here. So I have 1.1 times 0.95 times 2.54 times 0.69. And that is going to give me 1.83 cubic feet per second. And I had done the calculations ahead of time just so it would make this go a little bit easier. All right, so now we have to find our final. So I've got to add up my 2Q parking, my 2Q post. Okay, so we had our farmland, which we calculated over here to get this 1.13 cubic feet per second. So I have 1.13 cubic feet per second plus 1.83 cubic feet per second to give me a total of 2.96 cubic feet per second. And then from here, I've got to go find the difference. Okay, so I'm going to do a new blank slide. And we're going to do our Q post minus our Q pre. So our Q post, we just calculated 2.96. So we have 2.96 cubic feet per second minus our initial Q pre, which was 1.46. So we have 1.46 feet cubed per second. Okay, we subtract those two and we're going to get 1.5 feet cubed per second. And that is our additional stormwater runoff.